Hello, everybody. Welcome to the first, actually, Apache Airflow meetup in at Google. Okay, so my name is David Sabater. I'm a custom engineer at Google. I'm actually specialized in big data and scalable machine learning. So tonight we have a really interesting agenda. So we're going to start first with Kaxil about talking about the Apache Airflow project updates. I think he has a few nice, interesting updates. We're going to continue with Bas talking about Let It World, testing for fun. So I think that's going to be interesting. And then the last one is going to be me before the food. So hopefully you're not too hungry. I'm going to introduce Composer. It's our Airflow managed service. And I'm going to run a quick demo as well. And yeah, that's it. Hopefully you enjoy. Just if you don't mind, I'm going to take a picture. Say, Airflow. Great. Kaxil, over to you. Thank you.
Thank you all for coming here. Some familiar faces from the last meetup. Good to see. For those of you who don't know me, I'm Kakshil Nayak. I'm the organizer of the Apache Airflow meetup. I'm a data engineer at Data Reply UK. I'm Airflow PMC member and committer as well. Along with two other PMC members, we have Ash and Foko Dryspong. And I'm a huge cricket fan. It doesn't matter, but if you like cricket, we can have a talk. So I'm here to talk about what Apache Airflow has achieved within the last 1 year. So we have hit some milestones, and we also have some good project updates. First of the milestone was Cloud Composer. So Google adopted Apache Airflow to create their own managed service, which is just based on Airflow, right? So this is a milestone for us because it increased trust of the people, because the company like Google is using Airflow. So definitely this project is worthy of it. You can definitely see the reasons in their blog post. They said that we have an active and diverse developer community. So that was one of the bigger milestones for us. We reached 10,000 GitHub stars. I was very happy at that day. I posted on LinkedIn and shared to all of my friends as well. This is big enough because it shows that Airflow has gained popularity over the last 2.5 years. I forgot to mention that today we have around 10,800 stars, so we are definitely growing fast. This is one of the biggest news, that Apache Airflow is now a top-level project. So we started, Airflow went into incubation stage 2.5 years ago when Airbnb gave the project to Apache Software Foundation. So it was a long journey of 2.5 years, but it was definitely worth it. And what that means for users is Apache Software Foundation now backs Airflow. They know that we have followed their guidelines for 2.5 years. That's why we have gained an Apache graduation. And it also means that we would now have more frequent releases. Previously, when we were incubating, the release process was a bit longer, but now definitely it's a shorter process, so we would try and have more frequent releases. In last 2.5 years, the companies that have officially started using Airflow is from 32, we have jumped to 234. So this number is just the companies that have listed themselves on GitHub, on Airflow GitHub. I think the total companies would be more than 1,000, but these are the companies who have registered themselves. The number of contributors increased from 200 to around 600. We also managed to merge around 3,000 pull requests. Some of the biggest companies' names are Tesla, Airbnb, Twitter, Lyft, PayPal, Google, as they adopted Cloud Composer. I have also listed Data Reply. That's where I work, so I have to list it. So, we moved to Slack from Gitter last year around November or so, because Slack provides more features than Gitter, and we have almost 1,000 users on Slack. So if you haven't already signed up on Slack, you should sign up. And there are people like Ash, Foco, who can quickly answer to your problems. We also have a quite active mailing list. So if you are stuck into it, we can help you over there as well. So we released 1.10.2 yesterday. I had to change slides. So the slides initially said that we were on the way to release 1.10.2, but I was so excited yesterday that I just released it yesterday. Uh, Thank you. So some of the features, tons of bug fixes as always. We separate DAG parsing loop from scheduler loop. What that means is when you now put your DAG file in the DAG folder, you don't need to wait for, let's say, 2 minutes, 5 minutes. It would be directly showed in your web server. Improvements to Kubernetes executor and operator as well. Various improvements and theme support for RBAC UI. So for someone like me who likes their own colors, this is a good chance you can move to RBAC UI and change your theme. And if you manage to get a Darkula theme, please message me as well. Various new hooks and operators. So we have added like 15, 20 new operators for Google, around Google Cloud Functions, MySQL, Cloud SQL. We have added some for AWS as well, and we have added some sensors. One of them was weekday sensors. So if you only want to run your DAG on weekends, you can use that sensor. DAG level access control. This already existed, but it's more refined. And now you can create your own new roles. So a company can have viewer role, admin role, and then you can add some of your roles as well with some specific permissions. We have improved monitoring capabilities to integrate with StatsD and Prometheus. This is important when you want to make sure that your scheduler is running as expected, your metadatabase is active, you can use this. Improved documentation. So this was also in one of my agendas to do in 1.10.2, that we wanted to improve our documentations because people were confused in what documentation to follow, and some of it was not parsed properly. So this release has improved documentation as well. We have doubled our attendees. First meetup we had 2, now we had 4. No, just kidding. We had some 60, 70 in the last meetup, and we have almost 120 attendees signed up for today. Thank you. Now I'd like to call Bess.
The title of the talk, Let It Whirl. When Kaxil, the organizer of this meetup, asked me for a title of my talk, I was actually putting up my Christmas tree, and I had Christmas music on the background. That was the song, Let It Snow, Let It Snow, Let It Snow. So this title, Let It Whirl, popped up quite easily. So I gave this back to Kaxil, and he actually proposed to extend the title to let it be a bit more descriptive. So based on the abstract that I had already sent him, he proposed to add the second line, make Airflow development and testing fun again. And I think that's indeed actually the essence of what I want to talk to you about today. So I'm going to show you how we improved Airflow development and testing at my client. But even more so, it's about how we turn something difficult to work with into something to start enjoying again. So what can you expect in the next 50 minutes or so? Well, before I dive into the content, let me introduce myself and tell something about what Go Data Driven is. Then I'll sketch you the context of where the story that I'm about to tell actually took place. Then getting started / getting scared. I'll tell you about what we encountered when I first got involved with the history of Airflow DAGs that were already present at the client that I was in. Then let's kick this pig. So how did we turn this around, and how did we make a first improvement to get things better? Then full steam ahead, we did a second improvement, which really meant for us to make giant steps. And then finally, I'll conclude and tell you about expected next steps that we want to take. So I'm Bas Belen. I'm a Dutch guy. I live in the Netherlands, 34 years old. I'm currently working as a data engineer at Go Data Driven. I've been enjoying writing code ever since I was in high school, so that's around the mid-90s. That's also why I decided, to start to learn computer science. Did my bachelor and master degree at the Delft University of Technology. I started my career at Capgemini, and I made it extra small because I do not necessarily want to be associated with Capgemini. But to be fair, I actually learned a lot there because I was in a team with smart people, focusing on advanced planning and scheduling. So for example, implementing the software that they use to plan the public transportation in Amsterdam. And what I really loved about it was, the fun thing was trying to automate this planning using operational research technologies like, anyway. But then there was this itch to start working with writing custom software again. I got very intrigued by the possibilities of Scala. So that's why when I made a move to Xebia. Xebia is a one of, if not the top IT consultancy firm in the Netherlands. I worked for 3 years at the Xebia software development unit, writing a lot of microservices, distributed systems using Akka, Scala. I really love type level Scala stuff. But then around 2 years ago, I again desired a change because I wanted to get more familiar with what was going on in the big data and the data science world. So I made a move to Go Data Driven. And actually Go Data Driven is kind of a sibling of Xebia. So who's Go Data Driven? Well, this is us. This picture was taken last November when we celebrated the 5-year anniversary of the company. So we are a consultancy firm focusing on big data and data science, so helping our customers get the most value out of their data. We are with around 35 consultants. I think 1/3 is engineer, 2/3 is data scientists. We try to get it in balance. So if anyone in the audience is wanting to move to Amsterdam, you're more than welcome to grab a cup of coffee. One of the core values that we have is that we like to share knowledge, and we have these mini conferences every 2 weeks. There are 4 blocks, 1-hour sessions where you can book a room, do a presentation or have a discussion. And during one of those sessions, I actually did an early version of the talk that I'm giving you today. And in this session, my colleague, Foko Driesprong, he was also there. And Foko Driesprong, you might be familiar to the name because he's actually an avid committer to the Apache Airflow project. And he said, like, okay, maybe this is something, this is cool, and I think other people might enjoy this talk as well. So that's how he got me in touch with Kaxiel, and that's why I'm here on stage today. Before I move on, I want to mention one other colleague, that's Chris Geuzenbroek, because all of the stuff that I'm going to tell you about today, so I'm on stage here today, but we did the stuff together. So who's ING? Well, ING is a Dutch bank. It's the largest bank in the Netherlands, and it's a bank that's operating worldwide. And ING is also the client that I have been contracted with for the past year. And more specifically, I've been contracted by a rather young department called WBAA, which stands for Wholesale Banking Advanced Analytics. One of the founders of WBAA might sound familiar to you as well. That's Bolke de Bruin. I think he is the second largest committer to the Apache Airflow project and recently turned VP. So what does WBAA do? Well, they try to run a lot of experiments with big data. When they started, they were quite small, but like cowboys in a large corporate environment. And yeah, they did a lot of stuff with big data, so they built their first Hadoop cluster, try doing some machine learning on the data that they put on there. And then the idea is by doing these experiments, look what's the most promising, and then those projects that are most promising, they mature them into actual data products. So over the course of the years, they have like a couple of these data products. Now, I've been working for one of these products for the last year. I'm not about to tell too much about it, but in a nutshell, what we do is that we combine a lot of different data sources that are available within the bank, and we made that accessible through a fancy application that the internal employees can use. And on top of that, we add some machine learning algorithms to actually be able to serve them even more data than they would normally get out of these normal systems. So one last abbreviation, DAP. DAP stands for Data Analytics Platform. So last year, this new squad was erected who started to build this data analytics platform. You can think of the data analytics platform like a private cloud environment where its users, which are mainly data scientists and analysts, can spin up their own working environment with their latest data science tools installed for them, and just that all with the click of one button. It was also a necessity to get this data analytics platform available because the old Hadoop cluster just wasn't capable enough. It was not sufficient anymore to do the things that we wanted to do. So to shout out some numbers, this data analytics platform, has 5 petabytes of storage available. And unlike in the old Hadoop cluster, the storage is now separated from the compute. So they're actually using a technology called Ceph. They've got like 20 terabytes of RAM and around 5,000 cores for the computation. So maybe some of you might think in the audience, why not move to the public cloud? Well, the biggest issue here, is that they have a lot of sensitive data. It's not so easy to actually move that to the cloud. So it's a delicate matter. So that's why they're currently building their own thing. Maybe in the future they will move to Google Cloud, for example, but not for now. So with the arrival of this data analytics platform, we actually had to do something about the data pipelines and the processes that were running on the old cluster, on the old environment. Actually, my colleague and I, Chris and I, weren't yet in touch with what's going on with the Airflow DAGs and the pipelines. But because a lot of stuff had to be done, so we had to kick in there. And also the most knowledgeable guy in our team that actually was more involved with Airflow also left, so there was a gap to fill. And so I started to have a look around at the code base. You should imagine there's like, over the course of the years, I think over 5 years' time, there have been written a lot of Airflow DAGs by different people at different periods of time. And when Chris and I had a look, what we found was not so pretty actually. So there was a lot of code duplication going on. There was not much attention being paid to separation of concerns. So to name an example, there was a lot of hard-coded configuration within these DAGs. So when you're trying to move to a new environment and you have different configuration, it's pretty hard to change that. A lot of these DAGs didn't actually have unit tests, and I think unit tests are very welcoming to a new user, to a new user of a code base to get an understanding of what's going on. There were a couple of DAGs that actually did have unit tests, but you weren't able to run them locally because they depended on code that wasn't available within this code base. So for example, it could be a Spark submit operator which wasn't in Airflow release yet and was only available installed on the CI runner. Also, some of these DAGs didn't even have CI pipelines, so yeah, you could just commit your code and then yeah, break it and have no idea that it's broke somehow. And also, only a few of these pipelines did have DAG integrity test. I'm not sure if you're aware what a DAG integrity test is, but it's a part that you can. It's a test that you can add to your CI pipeline, and where you actually test that the DAG that you have defined, the code that defines your pipeline, is actually valid and is acceptable to Airflow. I think the most pressing issue that we found was that we had development, that's why it's in the middle and darker red. The development was being done in production, so we had one Airflow instance, and all the production data pipelines were running there. And if you wanted to make a change or you add a new DAG, you just commit your code, log in to a remote desktop, to the machine, check out the code there, or check out a different branch. It was very cumbersome to work with. Well, we couldn't say, let's just, don't touch these DAGs, because we had to touch all of these DAGs because we were moving to this new data analytics platform. So for one was that we had to change the code because previously we were using Hadoop HDFS, and we would now have to use Ceph. Ceph is actually has an S3 protocol, so you can think of like an S3 instance. And on the other way, something else that we had to change was the delivery of the data. Often they come in by files, and they would come in at a machine where we would expect the data, and sometimes this data would be in zip files. And we, in the old situation, we would unzip them on that virtual machine, and then put the data on HDFS. But the idea now was to get rid of all these virtual machines and let the delivery happen directly to Ceph. But then we would need some way to actually unzip these files. So the idea was to change that and use Spark for that. So on top of that, when this was all happening, there had been a security audit by ING on the old environment, and there were a lot of vulnerabilities found. So that actually meant that both the old environment as well as the new environment, we got even more restricted. So for example, we couldn't even become the Airflow user anymore. We couldn't use the Airflow command line interface. We weren't allowed to see what was actually stored on the Ceph instance. So it was pretty hard to work with. And then besides that, this data analytics platform was actually under high development, so it was not a really stable environment to actually work on. So we had to do something about it. Oh, you didn't see the slide yet, I guess, but that's what I just talked about. So what did we do to get around this, to make this better, to get a positive vibe? Because Chris and I weren't exactly, when we saw everything that we saw, we were in a very happy state. But we want to make things better. So I mentioned there was a lot of code duplication going on. So the third thing that we set to do was look at the common patterns of all these different ingestion DAGs. I'm now specifically talking about the DAGs of the data ingestion, and try to find the common patterns and use that, create a new Python module, which we named Airflow DAG utils. I moved that code to a separate Airflow a Python module. So here's an example of what this pattern looked like. What we try to do in all these data ingestion steps is that we move files that we got delivered from an SSH machine to the landing bucket on S3, and we do that only if the files that we expect exist. And this is actually the step that I mentioned, was eventually we want this step to be out of this process and let the delivery happen directly to Ceph. Then we do delivery from we move the files from landing. We pick up the files, we move them to the raw data bucket. We want to keep a history of all the files that we were ever sent so that we have all this data available, and in the case of an emergency, we want to redo our steps. Then we at least have the raw data files available. Then there's this third step, unzip, that only applies, of course, if we have zip files to work with. So we unzip the files to the process bucket. And then we run a Spark job to put the raw data in a Hive table, but still actually the same data that we already had from within the files. Then we often do a couple of transformations, which we call, and put that in Hive table as well, which we call the X tables. And then finally, we often run some DAG tests to see if the data that we ingested still makes sense for the whole data. So as I mentioned, with these steps in mind, we wanted to create an Airflow, a Python module, which we called Airflow DAG Utils module. And it consists of a lot of small building blocks that we can then start to use within these DAGs. So I listed a small function that's within this module in this slide, just to give an example. So this is a function that is called create S3 file availability task. You provided some input parameters. What's happening is here, say, okay, we construct the full path, joining the path and the file pattern. And in this case, we create a bash operator, which uses the AWS command line interface to test if this file exists on S3. And if so, if it doesn't, then we echo that we couldn't find it, and we exit with code 1. Otherwise, we say we found it. Is this the most elegant way to do this? Probably not. I think I recently saw S3 key sensor, which might be more plausible to use here. But the key thing is it's not about the implementation of the code, but the fact that we abstracted this into functions that we can use and share over all these DAGs that we're developing. So now if you want to make an improvement, we can just, in a single place, change the implementation, and it will have effect on all the existing DAGs that are using this. I hope this is readable in the back. I tried to make the fonts big, but yeah. So the Airflow DAG Utils module, we try to let it have a readable API. And this is what you see here on this slide is basically what is happening for all of these ingestion DAGs. So we define a couple of files that we expect to be there. It's a list of files with a pattern and a date in it, and most often that date will be the DAG run execution date. Then we define the DAG with DAG, and we provided some config, which I didn't put in the slide, but yeah, you can imagine what it is. And then we create, with this DAG, we create a generic pipeline. So that's a class that we've also defined in this Airflow DAG Utils module. And then we say with source from SSH, that's the first step. Okay, the input path is at the staging there. Consider these files, and the output path is then the landing bucket on S3. Next step, with source from S3, because we're expecting a file from S3 on the landing bucket, which we want to move to the raw data bucket at a different location. And for this location, we use the system name and the DAG run execution name to construct that path, that key. In the case of zip files, we can do call with multi-source extraction, which I didn't show you the contents of it. and then we say, okay, construct the ingestion pipeline, and that gives us the basis, the basic start of all our ingestion of the Airflow DAG. And then if you want to create Hive tables with it, we can extend that. So we have a create O table in this case, which is a fictional function to create the O table. And then we can say, okay, that's also an Airflow operator, and we can say pipeline per last task. Let the create O table task be a downstream of that Airflow DAG. All right, so we made a first improvement because we limited the amount of code duplication by creating this Airflow DAG utils module and having shared building blocks among the different projects that are using this. And we limited the amount we have a better separation of concern now. We got rid of all these hard-coded configuration. But we also now made it more difficult even to work with this, because we have now an extra dependency, which is a new Python module, which is a dependency that we have on the environment that we're working on, the development or the production environment. So that got actually harder, because how do you develop such a module if you can't really test the things that you're adding to this module, right? So yeah, we had to do something about that as well. So as I mentioned, for a few of these DAGs, we already had we did have a CI where we did DAG integrity test and unit test. So for the DAG integrity test to run in the CI, we depended on a Docker container which had Airflow installed to test the integrity of the DAG. And for the unit test, which was mainly testing your Spark code to see that the Hive tables were created, we had a container in that same Docker container, Hadoop and Spark installed. So we said, like, can we use that base image or that Docker container as a base image for running your Airflow DAGs on your local machine? So what would we require to actually make that happen? So first we need to have Airflow in a container. As I mentioned, or what you saw early in the slides, we were making a connection to another machine using SSH. So we would somehow need ability to actually perform that step to make an SSH connection. And in this case, we decided, can we make an SSH connection to the local host in that Docker container? Next, you would need to run some scripts, some configuration to actually, for example, make some mock data available at some location where you expected the data to be present. We would also need S3 technology, so keep as close to the production environment and actually use Ceph in a container. That's actually possible. And that's actually it for almost all the DAGs that we had running at ING. There's one exception to these DAGs, which also required Postgres and Druid to be available as well. Well, these run in a container also. So let me show you a couple of the code snippets, because I won't show you all the details, but let's go through a couple of these slides how we achieve this. So for the Spark Airflow container, how do we, for example, so that was our base image, so that's the Docker from Docker PySpark Airflow local. First thing that we had to do was install that AWS command line interface, because that was how we connected to Ceph. So we pip install that AWS command line interface and some plugin to actually change the configuration of the endpoint, because by default AWS command line interface will connect to Amazon Web Services. and we obviously need to connect to Ceph. Then we need to enable SSH to localhost. Yeah, this is the code to do that. Maybe not very obvious at first sight. We remove any existing SSH keys, then we add the SSH key to the authorized keys. We had to reinstall or like first remove the existing open SSH client and open SSH server because it appeared to be an old version. With that version, SSH localhost wouldn't work. So we removed that and we install the latest version, and then in the host.allow file we say that every client is allowed to connect to localhost. So what else? Obviously there's more going on, but I'm only showing you the most interesting bits. So for one thing, we said that we don't want the default Airflow load examples to be present, so we changed the configuration so that they don't load. And we also want debug logging. And then there's this entry point SH, which will start to run when you launch that container. So what's happening in there? Obviously, we need to connect to Ceph, and we talked about the landing bucket, the raw data bucket, the process bucket, and these should be available. So what we do here is a while loop, and we check, we try to connect to Ceph, and then we see what it returns. Using curl, we do that, and if it returns a 200 code, then we're actually okay to create these buckets. But if it's not there yet, then we have to wait for Ceph to come up. We need to tell Airflow that we expect some connection IDs to be available. So here we add the ingestion server, which on the production machine will point to the virtual machine where we actually want to expect the files to be there. But in our case, on our local case, we connect to localhost. And also we create a SparkProd connection ID, which also points to local. Next, so in the case of ING, we expect the files to arrive at staging DIL. We remove every file that might be there, and then for every DAG that we have in the DAGs folder, we CD to this directory. We expect the mock data to be at the subfolder mockdata/data, and we check if that's actually a valid directory, and if it is, then we copy all the data to the staging DIL directory. Otherwise, we print out no mock data found. Then we do something smart with the file names. There's too much code to show you on this slide, but to get an ID, I put it in comment. So we have these mock data files which have this format like there's a file with some variable, for example, ds underscore no dash, which we want to rename to a file with the current date without dashes. Similarly, you can say file underscore yesterday. That would then be yesterday's date, and there are a lot of variations possible. And then finally, but not less important, we actually want this Airflow DAG utils module that we're also creating to be available in development mode. So we pip install it in development mode. Okay, so we now have a container with Airflow and these extra SSH possibilities and stuff. But we also need now to connect all the containers, all these components that we have running. Again, I only show you a portion of the Docker Compose YAML that we have, and I only focus on the Airflow container. So we say in the Docker Compose file, okay, build this Docker container using the Docker file that I just showed you. Open up port 5000, because that's where the Airflow UI will be running. Then we expect some environment variables to be present, the mock data dir, the DAG folder, the DAG utils folder, and the project name. And then we mount several volumes using these environment variables. So we map the DAG folder to a folder in the DAGs, Airflow DAGs folder with the project name. We mount the mock data there to mock data. We mount the DAG utils folder to temp Airflow DAG utils. As you could see, that's where we pip installed it from. And we have to tell that this service depends on Ceph server. So if we start Airflow service, it will also automatically make sure that the Ceph server starts. Well, one final component. We need to have mock data. As I mentioned, we can copy some files, but in order for us to actually run this entire DAG locally, we need to have reasonable mock data. We didn't reinvent the wheel here, so we use Faker, which is a Python module, to construct this mock data. And then we have a wrapper around this, like a separate project which uses Faker. And then we can say, generate the mock data for us, and we provide it with a source for which we want to provide the mock data, and this date pattern that's here on the bottom. It's probably not readable for those in the back, but at least this gives us the mock data that we want, and we then can copy that to the mock data/data folder in the Airflow repository where we are working on. So then the next step, that's the world, that's the final glue to actually make this this local run happening. I thought of the name Whirl because it's kind of a wing to Airflow, but it spins in circles, and it's about fast iterative development. And maybe far-fetched, but you can also think as a whirl as a local Airflow, if you compare a whirl to a storm. But naming aside, what does this whirl script do? Before I started the presentation, you actually saw me typing in this command. So what is whirl? It's actually a bash script which will, I should change it here. What this script will do is it will define some variables. So we have the script here, that's actually the location of where this whirl script is located. Then we define the environment variables that we need. Then we look if there's an .airflow local run file available. So for every project we can define this .airflow local run file. And if it exists, then we read the services that we want to start from that file. So you can imagine that it contains Airflow, Postgres, Druid. But if there's no such file, then we just assume that you only want to use or start with the Airflow container, which then also spins up Ceph. Then we make sure that this base image where we depend on is actually built. So we do a Docker build of the Docker PySpark Airflow local Docker file. And then we run the Docker compose, providing the services that we defined. And what that then looks like, I'll switch back, or I want to switch back to my my screen. So I already set this. I started this in the beginning of the presentation because it will take some time to spin up. It's not interesting demo-wise to show that it happens. But I can show you that what I did is that there are now actually two Docker containers running. One is the local Airflow with Airflow, and the other one is Ceph. That's what we booted. There's one DAG here available. Let's enable it. And in the meantime, I can show you a bit of what's inside this DAG, and it will start to run. let me use the graph view here. So, for example, this with source from SSH, the ingestion pipeline is here for profile ingestion. Don't mind the name. But this function where we set generic pipeline and then with source from SSH, and then we provide the input path and the output path in the files, that actually resulted in these 6 Airflow tasks to be defined. So for every file, we actually have a test if the file is there, and if it's there, then we can actually do the move to landing, for example. And this happens for several places. In the meantime, this DAG is running, so we can see how far it is. So this file is actually, the code that we're running is the code that we would also run in production. There's no difference between what we run locally and in production. Obviously, it's mock data, so we can't go as far as assume that it will completely be exact the same result on production, but we at least can test that all the bits and pieces, all the code is actually doing what we expect it to do. Let me see how far we are. I would have hoped for this to go a little bit faster. Anyone having questions so far? Because I want to at least finish this run so that I can continue a thing that I want to show you. You have a question?
Yeah. So how are you?
Oh, wait. I think there's a microphone passing around. Let's see how far we are. We're getting there.
Cheers. So are you dynamically creating the structure of the DAG differently per run based on what files exist at the time?
Sorry again.
So the sort of pipeline that you're creating dynamically changes based off of the number of files that exist at the time?
Somehow the sound goes that direction, so
So is the number, like the sort of the tasks within your pipeline changing from run to run depending on which files exist on your server?
So you're asking if it will dynamically change depending on the files that I have inputted. Well,
so if there's 10 files on the server, it will have 10 parallel tasks.
Yeah, exactly. That's what's happening indeed.
So my understanding is that that's not how you're meant to use Airflow. That like you shouldn't have dynamic configuration of DAGs per run because the log keeps the history of all of the tasks, and you sort of end up with ghost tasks for.
The files are static per ingestion that we're doing. So we always expect these 3 files. So
are they the same names every single time?
Yeah.
Okay, cool. I've just sort of assumed that they would be different each day, but if that's the case,
no,
that makes sense.
Yeah. So to better clarify, so if there's this source X and there's this source Y, and they might have the one can expect 3 files, the other one expect 10 files. So that will change dynamically between the 2, of course. But for the same project, it will stay the same. So we always expect those files.
And the second part, slightly unrelated, but how are you capturing the scheduler logs when the Docker container dies? And so how do you persist those?
I don't, because it's not necessary for locally developing and testing what we're trying to achieve. So that will just, well, you can probably output them, because you can probably, the location where you have those, where the output of the logs is, you could, using Docker, you could use a volume to that location, and then somehow, that output will be written to that location, so you capture them, but we haven't found any need for that as of yet.
Cool, thank you.
I was wondering about values for connections and variables in Airflow. Have you had to kind of manage different values for those between staging, UAT, production. It's something I'm been messing with, and I was curious.
I think the pressing thing is that, so right now at ING we only have a production environment. So even this whole thing, we need to move there. So this was a first attempt to actually, well, not be dependent on any environment, but for us creating and changing those DAGs to have that available on our local machines. But we definitely need such a thing, and then we would encounter that. I think. Does that answer your question? Because you were saying that changing the connection IDs between those environments, right?
I was curious about that. Yeah.
You would. I think we would. Okay. I think now I better understand your question. You're saying, like, because that would change your code, right? Because you could say, I want to connect to the acceptance environment instead of the prod environment, and now we are specifying only the ingestion server or Spark prod. But I think, you could work around that.
So you can have two variables. For your first variable can point to two different variables. So you can have three different variables. The first variable can point to your second variable or third variable, and your second variable can be your configurations for your development environment, and your third variable can be your production environment. So this is how we generally use, and one of the blog posts I wrote recently had this in it as well. So you don't need to, you can parameterize your DAG, and then when you want to just switch between production and development, you just change the variable name.
Also, sorry. Yeah, also another way is, I think within the Docker file, you can probably parameterize some of these variables and then inject that into your local Airflow instance, right?
Yeah.
So multiple ways, but that's a good question.
Okay, so this is run and one task has failed, and that was intentionally because I made it fail to demonstrate one thing. So what's happening here is this test fails because 318 is not the same as 218 plus 1. That's because I added this plus 1 here. So you can just, I'm using my local editor here for the profile ingestion repository. I change this code and now I can go back to Airflow and I can restart that task. Clear this one, and let it run again, and now it should succeed. So because we have mounted my local directory to this Docker container, we can just live code and make a change directly and see what's happening in Airflow. And even more so, and this is the tricky bit, I have here the content of the Airflow DAG utils module. So let's, for example, say that I want to make a change here, and let's do a simple change and just rename these fork and these joints to branch and fuse. I save this. Because this Python module is installed in development mode, it should, in theory, also change here. But Airflow being Airflow, sometimes this won't immediately show an effect. And if it doesn't show immediately, so here, I think you see that it now changed, branch move and fuse move. Another option that we have also built in, but sometimes this is not working as expected, I could say we'll reset, which then will keep all the components that we have running alive, but it will only reset Airflow. So then this DAG will be loaded again. Where are we? And it will also, again, of course, have to be started from scratch. Okay, so that's for the demo. I think I want to go to the conclusion of the talk. So yeah, did we improve by doing all of this? As I mentioned, well, I think the main thing is that we can now locally develop, which is, I think, very cool and really also kind of a requirement from my perspective. Because we have now local development, we're actually able to test the Airflow DAG utils module that we were creating. So we could actually see that all these small building blocks were actually doing the things that we wanted to do. Because we had local development, we had to spend time on generating this mock data to be available. And because we had this mock data available, we could also use this mock data to write proper unit tests. So all the different projects now also have good unit tests. We fixed the CI pipelines. And regarding the DAG integrity test, we also limited the amount of code duplication there and created one DAG integrity test, which is also available for us in this Airflow DAG utils module. But aside from that, by doing this, we actually gained more. Happy people. So it was Chris and I, when we first started with touching these DAGs, we were kind of, okay, how do we cope with this? But it was actually very fun to create this. And not only fun creating this, but also fun in using this now to actually make progress. I also think that compared to the old situation, this definitely means a speed up for us because we can locally develop and test the DAGs. Also, if we find something weird happening on production, we can find the edge case, use the same data in the mock data generator, not exactly the same, but the same edge case, so to say. See that the DAG indeed fails locally, make the change, and write a proper unit test and see that everything is green again. And the third side effect is that it's very easy for new people to come in and start working with Airflow. So for one, ING is a large corporate organization, so it can definitely take quite, in the worst case, a few weeks for people to actually get access to the systems. But by providing them a way to locally run the Airflow DAGs, they get familiar with the code base right away and start making improvements. So I think these are great extra side effects. So what's next for us? Expected next steps for within ING. We really want to get rid of this one single Airflow production environment. Besides from having different environments, we actually want to move to using Airflow in Kubernetes. So that's something for us to work on. And in terms of using this Airflow local run project, my colleague Chris and I are really looking into how we can open source this. So we can, of course, exactly do this, what we did for ING, but there will be definitely ways to make locally, that do the same thing and extract the main components and make this easier to set up as well, make this available as an open source project. So we're looking into that, and hopefully we can have that online very soon. So that's actually it. That was my talk. Thanks for listening.
Any more questions? Nice.
Hi. When your task fails, does your CI server know about it? How does it know that it's failed and stop the pipeline from going further?
You mean whether we could of course run this in our CI. Currently we don't. If it would fail, then you would have to provide a check that somehow there's, I don't know exactly how to do it, But I think you could somehow extract that the last task failed and yeah, give a error code to your CI from there. But currently yeah, it's kind of a manual effort to actually test that the stuff is running locally, because some of these DAGs, running them from start to end can be quite long. So that's why we didn't add them yet to the CI. So how you would exactly go do that, I don't know from now, but I think that would be feasible. Did that answer the question?
Yes.
Okay, so I mean, thank you very much for the talk. It was really, really interesting. I love the different parts of it, and it looks very, very scalable. With Docker containers that SSH into the different servers to operate the different parts of the DAG, the amount of logs that come back off that must be so large. So how do you do you just put them all, pipe them all into an ELK stack, which you just kind of query from there, or how does kind of the logging work of all the different tasks that go into the DAG?
Yeah, so that's something that I think we want to improve when we open source this, because there's now a lot of stuff happening within one container, and that's actually too much. So we want, for example, Spark and Hadoop to run in a separate container, and so have Airflow only in a separate container as well. Right now, we didn't do anything special to extract these logs or put them in an elk stack, or so if something goes wrong, we just browse.
Okay. So they just sit in files on the disk wherever, or in the cluster, wherever the container's running, and you just read them as and when you need.
Yeah,
Okay,
we
perfect.
could, but so yeah, I haven't seen the necessity yet, because it's about trying to get the development better. So we just kill and restart again. Maybe I'm not entirely sure if I understand the question, but
No, I think it's fine. You've answered. It's just kind of the things which you're going to do later when it moves to a production environment.
so far we haven't found a necessity to actually export these logs to some place to do something with it.
Cool.
That's basically it. That's it?
Oh, sorry, I'm on. Do your developers have the ability to debug, like let's say they create a new operator? Can they debug that operator using their local Docker container in PyCharm, or is it just a matter of like running it and seeing if it produces the right results?
Yeah, so there are a couple of places where we, for example, I mentioned that we had our code already depending on an operator that was not yet in the Airflow version that we were using. And how we solve that is that you just add this operator to your code and use that operator. So that will be the way to go. So you have that. We created, for example, I think we created this contract folder, which then had this Airflow operator installed, and we could just use it and see that it worked.
Okay, thanks. And just a second question. What's your deployment cycle like? So how do you get something off your local machine and get that deployed into production when your production instance isn't inside a Docker container, so you're not deploying a container or anything, like you're just deploying, what, DAG code or something, or?
Yeah, so right now, okay, when we've done the development and we've tested that it is all green, we committed to, in our case, we committed to GitLab. GitLab has the CI, so we do the DAG integrity test and the unit test, so that at least we do those checks. Those are the checks that don't take too long. And then what happened? We actually log in to the machine right now, pull the latest version, and that gets then installed in the Airflow DAGs folder. So we're not allowed to actually install it in the user local Airflow directory, but we use a share, and there's like this rsync going on.
Okay,
So
thank you.
Manual step right now. All right, well, thanks again, and David is coming up now.
Cool. Okay. Thanks, Bas and Kaxil. So far, so good. Well, as I mentioned, my name is David Sabater. I'm a customer engineer at Google. And as I said before, this is the second actually meetup at Google we run. So the first one was actually in the Bay Area. I think it was back in September. It was also recorded, and there are the slides. And actually, at the end of the presentation, I've included them. And at the end, we will share again the record and all the slides, so you guys, you can review that later. Okay. So I'm going to talk about Composer. So as I mentioned before, Composer is our workflow orchestration tool, and is actually based on Airflow. It's a managed service running Airflow at the end. So let's start with a few trends, okay, and a few numbers, so we can actually get up to speed. So the first one, I probably don't need to get too much into the detail, right? This is the 3 Vs. It's all about big data, the velocity, the volume, and the variety of structured and unstructured data. So not too much to say that. The other one, which is probably something that we see more often, and we've seen that trend in all our customers, is about expanding the data platforms, not just in one single cloud provider and then also on-premise, but also across multiple cloud providers, right? So that's also a really important trend. And ultimately, is where is all that impact creating an impact, right? So can you raise your hand who kind of classify yourself as a data engineer? Okay. So you probably are familiar with that. And the next slide, you will probably feel even more familiar with that. Okay, so the point here is that there is more demands for the data engineers, right? So you can imagine you have all these Vs, then you have all these different platforms, and not just different platforms on the cloud, but also what is happening on-prem, right? So you still need to kind of rely on your legacy database and all these things. So all this is accumulating. And you have your daily work, and also on top of that, you need to learn all these platforms. So yeah, totally cool, right? So that's why we have all these meetups, to learn all this stuff. So some numbers as well. So in terms of companies, so and that's based on that company that they run, the analysts. We have 90% of companies, they are either currently, that's 85%, and actually planning to adopt cloud, moving to the cloud, public cloud. On top of that, we have within that 85% that actually currently they are deploying in public cloud, we have 81% that are actually deploying across multiple cloud vendors, right? Not just Google, maybe the other ones as well. And then also, on top of that, we have 95% of that same quantity of customers that they actually still increasing their investment in their own current on-premise solutions, right? It's not like they are all into cloud. You need to coexist. Everything needs to coexist. So again, adding more into the mix. So basically, what we are ending up is having a hybrid cloud environment, okay? So again, back to ourselves, data engineers, right? What happens with that? So basically, what happens is that we need to learn all these different processes, all these different connectors for the legacy systems, and then for the new ones, catch up with the SDKs, new versions of the SDKs on the different cloud providers. So we need to keep up with all this stuff, right? Also, infrastructure providers, we change, right? We release new API versions. We try to keep the previous versions, but you need to keep up learning all these things. So again, a bit of a challenge there. So what do we want, right? That's a key thing, what we would like to have. So we would like to have a really simple way to create a data workflow that can actually run across multiple clouds and actually also on-prem, right? We want to be familiar with the tooling we are using for that. So we kind of thinking that we have been working with that particular language. So we want to bring that up and then use the same thing. We don't want lock-in. So we want that if I'm running this particular workflow there, I want to actually take that code and run it somewhere else. So I don't want to be locked into a particular platform. So we want all these things, obviously reliability. We want the thing to be up and running and have our SLAs. And when we need to go there, is there. Okay, so that's what we want. Well, what we get, typically, is only this part. So this is typically, doesn't mean that it's everywhere, right? But typically what you get is simplicity. You actually have some framework on where you can actually build your pipelines, right? You have reliability because there are platforms that they can actually guarantee that for you, managed services and things like that. But then there are other things that are typically lacking, like you typically are more cloud specific, then you miss a bit on the on-prem side of things. You also have typically lock-ins because you need to learn a new framework, and then that's really specific for that platform. and then you need to stick to that and continue on that platform. Familiarity, sometimes you need to learn a new language, a new framework, new SDKs and things like that. So again, you are missing all these things, right? And again, multi-cloud in some instances. So all these things are really what we like to have, okay? Yeah, that's kind of madness. Yeah, so then what we see is that, okay, let's try to see if we can fill that gap, right? So let's try Google. What we did is, and that's what Feng mentioned as well in September, is let's see how can we address all these things with what we have as well. Because at Google, we are already managing, we're managing kind of massive workloads. We have our schedulers and all this stuff. But the challenge there is that if we go back to one of these things, is, for example, we want to rely on-prem, we want to rely on other cloud providers, right? So we don't have that because obviously we don't need to rely on these things. We run our own workloads. So that's why we ended up kind of selecting Airflow as the open source framework to host that managed service. And really, when I introduce Cloud Composer, it goes back into these 4 main pillars. So we want easy workflow orchestration. Okay, again, back to the point about we want to have easy lives because we have already, as Bas mentioned, you have a lot of logic to implement and test and revalidate, right, to go into production. You want open source at its core because actually open source is an enable for you to have portability. So you can actually have a pipeline built in a particular way and you can actually run that anywhere. You also want to have hybrid and multi-cloud environments. So not just across cloud providers, but also on-prem, right? That's important. And then that's a good thing for us. You also want GCP integration because if you're running that as a managed service with Google Cloud, you can actually have a single pane of glass and then being able to manage all your GCP components, right, within the same managed service. So that's quite good. Okay. So let's start with the first one. So making data orchestration or lives easy. Basically, the first thing and the most important is the framework. When you are working as a developer implementing your logic, the main thing that you want is to have a familiar language, so you can actually go there and start coding your logic. And then goes Python, right? Because Python is for data pipelines. Is kind of everybody kind of starts with their pipelines with Python. So it's really good to get up to speed with that because almost everybody's familiar with that, right? So you have a lot of people that is able to go and then understand the framework and start using it. So that's really good. And yeah, there are a few stats about who's using Python. Anyone not using Python here for the data pipelines? Okay, that's good. There are other platforms anyway. Okay, so another aspect about easy to facilitate our lives, right? That we get out of Composer. So the first thing is about one-click deployment. When I run the demo, you will see the UI, the interface, but it's the main thing when you have all the complexities of the logic and the business and kind of trying to get and generate your insights. The thing that you don't want to worry is about spinning up an environment, setting up the high availability of your workers and the UI is working and all these things, right? You want one click and then you have that deployed. The other thing is also about how you deploy your DAGs. You really want to automate that process. You want to automate a script, but then also you want to, when you're experimenting, you are in development, you also want to have some sort of interface for you to deploy your DAG and then experiment with that, okay? So that's also available with Composer. So you want to kind of facilitate your life. It doesn't mean that it's going to solve everything, but yeah, at least alleviate some stuff. And also, you want to leverage whatever Airflow gives you, right? So that's really good about Airflow is that it gives you a lot of different views about what your DAGs are doing. So you have different views about, depending if you're looking for SLAs, the timing about your tasks individually, about the execution of the multiple DAGs across the different days or different hours. Okay, you have all these views, which is really good to control your execution of your DAGs. And you get actually that directly from Airflow. Okay, so far, good? So that's on the easy part to facilitate. Now, let's move into the integration with GCP, right? Basically, what we want is to make GCP easy, because the thing is, when you start, you imagine it's like a toolbox. You have a lot of tools, and then you're excited. Oh, I want to use that. I want to create my pipeline and call this ML thing, and then reach with that, and so on. you want something in between to wire these things, right? You may actually think, okay, I can actually do streaming, and then I can do all this stuff in Spark. But then you actually start thinking, okay, but I need to schedule, I need to actually create dependencies and have that. So if you can actually abstract that into something like Composer, Airflow, that's really powerful. And that's really the point here, is just you have all these building blocks, and then with Composer, you can actually wire all these things together and have replicability. So you can run that into this environment and then into this one. And ultimately, what you're running there, you can run it anywhere. So that's also really good. The point is that you can still point to GCP services from anywhere, right? Or any cloud provider. We also have, within the GCP, we can actually have, we can touch on a lot of connectors and services we have, and I will go into that on the next one. So we have, as I mentioned, a really big list of components that we integrate with. So BigQuery is a data warehouse managed service, cloud storage, S3 equivalent for the ones that are from AWS, PubSub, messaging, Dataflow, Dataproc. These are the main ones. ML Engine is to train and deploy your own models from TensorFlow, scikit-learn and other ones. And there are more coming also from our partners, right? As Kaxil mentioned, we have cloud functions, we have also Kubernetes, we have GC. There is a bunch of them coming up, right? If they're not there already. So this is really good because you can actually go straight and integrate with your own services. So this is just to show you how really looks in terms of the console. Again, I will go through them, and I will show you a little bit about how to interact with the console. This is where you go into console, you define what you need, number of workers, that's the typical thing, the type of nodes that you need, some specific Airflow configuration parameters, and so on. You can define levels to define that, subnetwork, a lot of things. One important aspect we have noticed is about enabling beta features. I think someone mentioned already there that it's sometimes easy to find where it is. I will show you again on the demo where you could find these beta features, at least the switch to enable that. Okay. Moving on. Again, when the environment is deployed, then you can actually interact and then see all the configuration parameters, Python dependencies as well. You can inject. Then you can also interact with your Airflow properties. So you have a bunch of ways to interact with that, okay? Next one is about open source, right? That we mentioned that before. So first, we have an amazing community of people contributing to Airflow. We are also contributing, and actually, more and more, we are helping the Airflow project, not just with our own connectors, but also solving other main challenges. And just to explain a little bit how it runs, so we have actually, high level, we have our own GitHub repo or Git repo internally, and we do some patching into Airflow, right, to make it managed service for us, scalable and things like that. And the point I'm making there about watch this space that we're actually planning to release in the few months some of these changes. So we are going to actually, not just with the connectors and any other thing, we're actually going to contribute back into the community with our own kind of settings to improve the stability and then how to manage Airflow. So I think that's really good. Also, we have well-established interfaces, existing ones, right? So you don't need to actually go and build from scratch something. You might actually have a connector for your DB or things like that. So that's, again, really good. And that comes from the open source community, right? So you don't need to go and start that from scratch. Also, open source, what facilitates is, okay, I have this operator which is similar with what I need, but actually it's not exactly compatible with my APIs or whatever. You can actually take that code and then prepare for your own kind of interfaces. That's really good again. You don't get that with vendors, proprietary vendors, and where you don't have access to the code. So again, really powerful. Okay. Yeah, that's the point I mentioned before. We believe that open source is your portability insurance, right? Because when you're running things with open source and Apache project, you know that you can take that pipeline and then run it somewhere else. You're not stuck into a single vendor. And yeah, typically question we are being asked is, why are you doing that? Because you're opening that out, right? So everybody can say, okay, I'm gonna take your code and then I'm gonna run it on my own place. The point is that what we believe is that when you try and then run with our own services, you will probably stay, because what we want is to have a really good quality of service, and then we're trying to guarantee that. So even we promote open source, we believe that when you start with a GCP, you will probably stick, okay? And again, we also believe that the code that you are building for your logic is very important, right? So we don't want to obfuscate that. We want you to keep ownership of that logic. If you were using a private platform, that logic stays into that platform, right? We don't want that. We want for you to move them along, okay? So you want these workflows to be portable. Are we done? Yeah. Again, rich library of connectors. On the right side, you can see some examples from GCP, but we have also from other cloud vendors, so that's good. Again, we want to be open and not just restrict things into our own platform, right? You want really to be hybrid, not just across on-prem, but also across other cloud vendors. Yeah, I mean, easy to use experience. What we do with our connectors is trying to be compatible with our latest APIs as well with the previous ones, and then you have all the features. Whenever there is a new feature in one of our services, then you should be able to actually access that from the connector, from the GCP connector, okay? That's also important. The next one is about hybrid, right? How can we actually be hybrid and having that view about being multi-cloud compatible? Going back to the numbers, I won't repeat myself, but that's the thing about the reality is that the one at the end is still companies, 95% of the companies, they still need to go through actually all their on-prem workloads. That's, again, still very important. Yeah, at the end, the whole thing is that is the new reality if it's already the reality, right? That we are working with, for example, in the case of ING, that they might actually start opening some workloads to run in cloud, but they might still need to keep things running on-prem, right? Because of this data sensitivity or things like that. So you want to enable that, right? Because you don't want to restrict things to run on-prem and stick there because that platform doesn't work on cloud or doesn't interact with your services in the cloud. You really don't want that. That's important. So that's the thing about examining the typical environment, right? It's not just between clouds, but actually it's on-prem, and that's very important. Now, if we go back to what we built into each of these environments, we need to build this workflow, right? This pipeline. If we go into what typically happens in our silos is that you start with a particular vendor on a particular cloud, and then you do the same on-prem and again, all over again on a new cloud vendor. So you can see that actually doesn't scale too much because you as a data engineer, you need to learn how this works and all the points and the framework and how you wire these things, right? How you create your pipelines. Same goes with on-prem, and then same goes with the other cloud vendor, right? Again, that's not helping. Again, if you want to really then integrate all these things together, you're going to need to learn also how you can actually abstract and connect all these things, right? You have a pipeline here, a pipeline here, and a pipeline there, and then you need to probably mix things coming from these pipelines. Again, that's a compound effect into what you need to come up for a solution to integrate all these things, right? That doesn't help. So the point is, that's where Composer and Airflow sits, right? That's somewhere you can actually integrate all these things together. What ultimately you have is a single pane of glass on where every single part of this workflow is actually managed by Airflow Composer, okay? So that means that actually you can share the same framework, so using the same framework, the same pipelines, the same code, and you understand what you're doing. You don't need to learn all over again the different frameworks, the different code, and SDK and things like that. So that's really powerful. You still have 26 points of iteration, but still, you will use the same. You will use a combination of operators that you understand, and they typically follow the same pattern. So again, that's really, really powerful. Okay. Summarizing, end-to-end GCP integration, hybrid, multi-cloud, as I mentioned, easy to facilitate our lives. And then ultimately open source as well to be not to be a portability insurance. That's the term. Okay. Some references about clients. I think you mentioned, I forgot about Blue Apron. They were quite early in the process of even when we had alpha for Composer, they were really interested, and then they were really alpha adopters, early adopters. So that was really, really encouraging. And we have many more. We cannot share to some extent, but yeah, we have a lot of them. And that's really, really exciting because we can also contribute back to the community with the lessons learned. Okay? Any questions so far? Good? Okay. I'm going to go into demo. Just before we switch, sorry. Just quickly what I'm going to show. There is an example that you can follow. Basically, what I'm going to do is I'm going to rely on GCP services. We're at Google, so I'm going to do that. What we're going to do is we have a bunch of tables in BigQuery in the US. I'm going to instruct a pipeline to transfer this number of tables to EU. I'm going to use some buckets to do that transition staging area. I'm going to use Composer for that, and I'm going to generate some logs that they will land into Stackdriver, which is our logging managed service. Okay, so that's pretty much. Okay, can we switch into demo, please? Okay, so what we have here is the console I mentioned before. Okay, this is our GCP console. Just refreshing just in case. Right, so I created already 2 environments there to kind of continue with the demo, and we don't delay too much. But basically what you can see is that this is one of the first things I wanted to see. That's where you enable beta features, okay? Very important, it's a bit hidden there. And when you start creating the environment, you no longer see that. So if you don't click beta there and you click create, you won't see that feature. So for example, you won't get any beta features enabled on that one. But if you click it, I know it's silly, but I've been quite a few times, where is my beta feature? So you can see now that there are beta features there, okay? That's just a highlight. So for the demo, what I'm going to do is I'm going to use 1.10.0, which is that environment. Again, an environment is just a cluster, a production cluster where you have a number of workers, your web server, and we fully manage the web server and also the database for your metadata, so you don't need to worry about that. The workers and Celery and scheduler and all the stuff, they sit in your own Kubernetes project, so you can actually interact with this, okay? But not with the web server and the SQL. So basically what you can see here is that we have an existing environment. We're using 1.10. This is our own version of Composer. We also, as I mentioned, we patch and we use our own versions internally. This is the type of machine we're using for the workers. And most importantly, this is on where we deploy our DAGs. As I mentioned, you can actually, programmatically, you can deploy the DAG, but also you can go into the DAG, and then you can upload that Python model yourself manually, okay? So as you can see, we have here 2 models. We have the Python code, and also we have that CSV, which basically contains the names, the tables that we want to transfer, okay? So if I'm going back here, I can then open my Airflow web UI. The good thing also, and that's why you really love to run Airflow in Composer, is that, for example, when you click into that one, web server, if you were running that as vanilla, that's open to everybody, right? So if you were running that your own in public cloud, you will open that to the entire world. What we did is actually, this is behind identity-aware proxy. So this is a service that you need to be authenticated on your project, on your Google project. And then when that opens, you need to authenticate, and otherwise you wouldn't see that UI, right? So that's protected, very important. So we have here the DAG, okay? What I'm gonna show you quickly is the code. In this particular case, it's similar to the example you meant, the code you mentioned. We have, well, the typical thing, we import all the dependencies. We have the default arguments, some variables that we use. Basically, what we have defined already in Airflow is that list of the file that contains the list of tables, the staging source bucket that is actually in US, and the destination bucket that is in Europe. Okay. Then we have a simple function. It's a for loop We're not doing anything fancy, so we know that we are creating a static list. We don't need to do any lazy execution, any yields or anything like that. So we do a for, and we populate that list with the tables that we want. The nice thing about that is this is creating a dynamic DAG, right? But only once, and you, again, back to your point, you don't want to change that, but you can start with a specific DAG that is able to, I don't know, migrate 2 tables, like in this case, or 1,000 tables. It will programmatically build the DAG to either process 2 or 1,000, okay? So that's really good as well, just based on that file. Yeah, same as typically we have a DAG that defines that. This is the for loop that builds our DAG dynamically, okay? So we're also using loggers. Another nice feature about running Airflow in Composer or Airflow in Google Cloud is that every single log that you define there, it will end up into Stackdriver, which is our logging managed service. So you can actually always go into that console and then find out what's going on, right? Not just for the service itself, but also for your own code. Okay, so that's pretty much. So what I can do is just kick off the job. I should have done that because it takes a few minutes, but I can't keep talking. So basically, this is running now. And as I mentioned before, there are multiple views that you can have from the DAG. You have that one about every single instance of your DAG, the execution. So you can see that the previous ones, they succeed. I very much like this one. That's the typical one to see how is your tree, right? All the dependencies. Basically, what you do at the end of the DAG is define you wire these dependencies, these tasks. So basically, what we have is dynamically we have created 2 pipelines. One for this, basically there is this data set called New York taxi trips. And there are, I think, 2 years of worth of data. I think is 2.4 and 1.7 gigabytes of data. So basically now I'm transferring data across Atlantic within Google network, okay? So I'm gonna keep refreshing a few times. So you can see that first thing is to export data. That's being now transferred from GC's US to GC's Europe. And this is running there, so that's good. I can, in the meantime, go and check with BigQuery. So if I'm checking quickly I see that this is my landing data set. This is like the schema definition in BigQuery terms. So that's where we're gonna end up having 2 tables, right? So we need to keep refreshing a little bit while this is running. But the whole point is here that you can see that, let me open a new one and then keep that running. And go back to Composer. Okay, so as you see, this instance is running also in West 1 Europe. Doesn't really matter where you're running because actually that environment is not really processing any data, right? It's orchestrating sending all these gigabytes from EUS to EU through BigQuery, bucket, BigQuery. Okay, that's really powerful. And it also is important because sometimes you might feel that, okay, if I'm doing something, am I sending all this data through Airflow? No. If we're talking big data, you don't really want to do that, okay? So that's important. Okay, that's running. Let's see the DAG, how it's doing. Okay, it's in the process of copying. It's taking some time. So we can also check the code. As I mentioned before, that's down here. That's how we're doing all the wiring. These start and end tasks, the kind of dummy operators. So sometimes you really want, as you build the DAG, you really want to have a shape that you can understand, and you use dummy operators for that. So that's really handy as well. Or when you need a specific dependencies that all need to kind of finish to a specific node and then start from there. So it's more visual, but at the end it has some usage. Okay. Yeah, you can see also that we have kind of very similar naming convention, the way you call the task IDs, and then you typically rely on very similar. And then ultimately, all this relies on our own GCP services APIs. Yeah, come on.
So you said
Can we bring a, sorry. No, it's there. Sorry about that.
So can you still view the logs through the Airflow UI even though they're being shipped off to?
That's also there. Yeah. So if I'm going here, I can click on the doc and yeah, I missed the doc. They are there, so you can always. And if I'm doing the same, actually from here, I can see them in Stackdriver. And then you have very similar ones. Obviously, you have also other logs as part of your environment about what your web server, your Celery, and all this stuff, all the other components are doing. Then you can create your own filters again here and consolidate and export that into other systems if you need. But yeah, you have that available from both sides. Yeah, good question.
Sorry, talking to myself. I said that shouldn't be called logs because it's not audit. So
Well, we have audits, but we have logs as well. So these are all.
that screen.
Yeah, that specific screen. But you can also, we have audits actually on where you can define rules and then create alerts and monitoring your SLAs as well. You can define all these rules into a Stackdriver. But again, this is about Airflow. It's not about, and Composer, not about. But yeah, it's a good point. Okay, so let's see if this guy is finishing. Yeah, so it finished. That's good. We transfer 4 gigabytes, a couple of minutes from US to EU. We use a super fast network. Sorry, I'm a bit sales guy, so I need to always. So you can see here that we have now 2 tables. And then if I'm clicking in details, you see that this one is 2.27 and this one is 1.43, right? So that's it really. I can even show you that a preview of the data is there, so that's really good. And then again, you keep track of all these executions, and same way I did this one, I executed 4 times already. So again, you keep track of all these things. This is within Airflow UI. Okay, cool. That's all I had on the demo. Can we switch back to presentation, please? Thanks. Any questions about the demo? Cool. We're going to have time where we have food, drinks to talk about and so on, so that's good. Okay, so a few updates about Composer. We heard about Airflow. I'm going to talk now a bit about Composer. What I try to do here is that, as I mentioned before, we had a meetup back in Bay Area, and I think it was Sunnyvale, back in September with Feng and James Malone, which are, Feng is the tech lead for Composer within Google, and James Malone is the program manager. Since then, we have 2 main announcements. There are a bunch more. The link is there and where you can go with the release notes. But I think the most important one is about Python 3. So I think that had to be. So it's GA. So you can actually, when you deploy, create your environment, you can decide whether you use Python 2, Python 3. The other one, which is still in beta, is to have multiple versions. So by default, when you don't select beta, you can only deploy 1.9 at the moment. Okay, that's going to change soon, but still we're in beta, so we need to go through the proper process to data quality assurance and things like that, like any other software company. But what you can do is enable beta, and then you can actually deploy either 1.9 or 1.10. Right now is 1.10.0, but soon will be 1.10.1. Okay, someone mentioned 3, but yeah, it takes time. Okay, so that's on the features. And just to wrap up, there's a bunch of resources here that you can actually go. Obviously, there is the Airflow, but also we have on the Composer. There is a Stack Overflow. We have also included slides and videos from the previous one. Yeah, and I think that's a wrap. Any questions? Composer? No. It's GA. What is beta is actually it's a good point. Beta is only when you need to, for example, enable things like a multi-version. But Composer is GA, general availability. Yeah, fully supported. Come next.
Hi there. A very quick question. Supposing you're building DAGs that have require additional Python packages. I think I'm aware that you can install those from Pipey, but if you've got like an internal repository of your own developed packages that you need to use in DAGs, does Cloud Composer have a technical solution for that at the moment?
That's a good point. You will probably need to somehow, through pip, through a requirement to install that. So that's because what we do is pip install these packages. What happens is you define these dependencies when you create the environment, and then when we build the images, then we bring these dependencies there. So that's typically how it's run now. But it's a good point. And what typically you do is you take that as your own modules, and then you take that as a plugin or within your DAGs or things like that. So there are multiple ways. But yeah, you need to rely on pip packages for that, to have that automated. Yeah.
Does that go beyond pip packages as well? So like Linux dependencies and stuff like that. Can you install those?
No, it's just on Python dependencies. Yeah. So if you need things like more on the operating system dependencies that maybe are required for a particular operator, that is not really, you cannot get that because that area is protected. Yeah, for stability, basically. Yeah. Otherwise, even with Python packages, that can become sometimes a bit problematic because we all know that Python packages version inconsistency can break things. So that's something always that, as part of the development cycle of your DAGs, you really need to validate that you are not breaking things by introducing very specific versions of your packages or your dependencies. Yeah, but it doesn't go beyond that. I think there was also a question here. Yeah.
Yeah. About cluster scaling, is it possible to scale up and down the number of workers?
It's a good question. There's always someone asking that. Not at the moment, but there is. It's in the roadmap. Yeah, cannot say when, but it's in the roadmap.
And when it's there, will it be automatic scaling based on queue length, or?
It will be more than that, but yeah, that's in the roadmap. Obviously, there is the easy answer is that we can enable that and have a bit more auto-scaling enabling to the existing solution, but there is more into that. So yeah, but yeah, it's in the roadmap. Question here.
So the enable beta mode at the top right corner, does it also show you what features are in beta?
Yeah, so when you enable that and you go into create an environment, there is a tag there saying, okay, this new setting is in beta. So you see that tag. When I enabled that on the multi-version, I probably did it too fast. There is a tag there saying beta. Yeah.
Okay.
Yeah, so you know if you are really in beta or not. It's important. See.
Tying the two talks together, so Cloud Composer you've said you've patched Airflow a bit. Is there anything significant in those patches that would stop you running it locally in the same way that Go Data Driven have done? Would you be able to run it locally and then just go straight to Cloud Composer?
I'm not the best person to talk exactly about the patches, but I don't think there will be any particular thing blocking that. Yeah, it's more about making that scalable and then compatible with certain services we have, but yeah, nothing beyond that. Should still work. Yeah, good point. The main point about us making sure that when we release that it works is to ensure that that is the case, right? a good point.
Yeah, you can actually pull the Cloud Composer images, so you can look into what they patched, and then you can check it out.
Yeah, they're available. At the end of the day, what you don't get is the metadata database and the web server, which actually the web server, the use cases where you don't want to expose the web server in that particular way. So even if you know that you are protected with the entity-aware proxy, you don't really want that. There is a way also to spin up your own web server version with, again, within your G-key, with your Kubernetes cluster. Yeah. Are we with the time? Oh, we're good. We're good. We're good.
Yeah, I hope it's going to be a quick one. What exactly was contributed by Google so far?
Sorry?
What exactly was contributed by Google so far?
Well, we can probably go into GitHub and see the contributions. But yeah, I mean, obviously we make more emphasis into the operators and the hooks that are part of GCP. But we also...
Other than that?
Yeah, we also in the stability and so on. So for the whole point about Google is I'm not part of the product team, but also contributing to into Airflow. So it's not really a point about who is doing it. It's the whole kind of community. We are really involved into the Apache communities, not just Airflow, also Beam, TensorFlow, as probably you know. So we are really heavy believers of open source. Yeah. Probably on this one, I will probably say the focus obviously makes sense to be on the operators because we need to keep them aligned with the features, but also in the stability of Airflow. We want Airflow to be stable, so when there is a new release, we can actually quickly embed that into our own managed service. So it's in our own benefit as well to be able to contribute, and we do. Yeah. We also have partners that they focus on some particular. For example, we have partners that they work into operators to improve the operators as well. So it's not just Googlers, so we have partners working on that. Yeah. Thanks. Sure. This is like I'm getting tan.
Hi, I was wondering if in the product roadmap there is upgrade feature, like you want to live upgrade to a new version instead of destroy the cluster and recreate it from scratch?
That's a good point. I will probably need to look at our friends and the community because it depends on the version. Obviously, the upgrade is more dramatic because you need to kind of start from scratch in some instances because of your metadata is not compatible and things like that. So I will probably say that there is nothing on the roadmap that addresses the major versions. But yeah, it's something probably I can have a look and ask the guys and see whether we have something on the minor versions. So for example, 10.0, 10.1 kind of thing. I will ask the guys. Yeah, that's a good question.
Because I using it, and every time it's kind of painful need to create a new one.
Yeah. Yeah, main thing is the metadata, right? So you want to keep all the historical executions.
Exactly.
That's the good thing about the stack driver, because you will drop your environment, but actually all these logs, obviously you don't get the DAX executions, but you still keep the logs of all your executions, which is good. It's not ideal, but yeah.
And changing machine types?
No, that's not available because that depends on your Kubernetes cluster. And yeah, you need to really recreate the workers. Yeah, that's not there. But again, that's another good question. I will take the two and yeah, follow up. Thank you. Somewhere here. Wow, that's a lot of questions. That's good. Yeah, we're good. Well, the only thing is food is going to start serve if it's not there already. We have drinks. Food is there, yeah. Good. And at 9, we need to leave because the guys, they need to tidy up and then they need to go home as well. So yeah, that's the only thing. Yeah.
Hi, thanks very much for the presentation. My question is about, let's say I want to make some changes in some of the code base. Let's say I'm going to add a new hook or a new operator, new sensor, and I want it to be in a Google Composer. Sure. And how is it going to be? Can you show us maybe?
Yeah, I mean,
how I can change it.
Yeah, I will probably say that it shouldn't differentiate from what is with Airflow currently. So basically, you have two options: is as a plugin or actually as a proper module package. But yeah,
This is a bugbear of mine, actually, which is there is the thing called plugins, but most of the time you don't need to use them. If you're writing a hook or an operator or a sensor, it is just a Python module. Put it in your DAG tree, import it like a normal Python module and class, and use it.
Yeah.
It doesn't need to live under Airflow. It doesn't need to be tied into Airflow. It's just a Python class. Just use it, write it like a normal Python class, put it in your DAG tree, and it just works. So it's easier than you might think.
Exactly. Yeah, and similar back to the dependencies point, right? If you can actually have your dependencies as Python modules inside your DAGs tree, that's also possible, right? You deploy a project as a DAG, and that should be compatible as well. And again, no difference from Airflow with Composer. Yeah. Cool. Any more? Good. Thank you.